So the first example of tree diagram where we remove items, we have two options and we have two choices. So this tree diagram is going to be like, so first choice, we have two options. It can either be red or it can be blue. Okay, first, if first option has been taken, then second option, it can either be red or it can be blue. Now if the, on the other hand, if the first option was blue, then the second choice can be, it can either be red or it can be blue. So that is the first category of tree diagram where we have two options, meaning two colors to choose from, and we are choosing or removing two items. So let me write this down. This means removing two items without replacement. That basically means the probability is going to change every time you do the calculations. So here, before even filling up the tree diagram, let's see what are the sample space. What are the possibilities? So the possibilities are red and red. Then we have blue and blue. So this is a blue and blue. Then we have red and blue. Making a tree diagram really gives you a clear idea of what are the permutations possible. And we have blue and red. So these are the possibilities. So when they're talking about the permutations, what is the permutation of same color? So that's a very common question. Find the probability that it is going to be same color. So probability of same color, that means this option, red and red or blue and blue. So these two are the permutations, red and red or blue and blue. That is probability of same color. Now the next question is, what is the probability of different color? So probability of different color. So when the question is probability of different color, one thing is very important to notice is that we have two options. Whenever there are two options and you're removing two items, we can use a special technique over here. Probability of different color, usually we have two permutations. It is red and blue or blue and red. That is basically probability of different color. But another approach of doing this math is thinking of probability of different color as the not rule of probability. There is a not rule of probability. And the not rule says that if you want to find the probability of no, that means it is 1 minus probability of yes. That is the not rule. Or if you want to find the probability of yes, it is 1 minus probability of no. So the concept here is probability of different color is the same as probability of not same color. And that is true if you take a look at the tree diagram, all the sample space, all the possible outcomes. So if you just remove red and blue from the total probability, and the total probability is 1, you will get red and blue or blue and red. That's the idea. So there are two ways of doing this sum, either thinking of this as the not same color or thinking of them as different color, red blue or blue red. So it's the same thing. So since in the previous math, if you find the same color, so the best thing to do is to do 1 minus same color. That is much easier to do than do the different color concept. Now another question that is specifically a question for a tree diagram where we have two options and we are removing two items without replacement. This is a specific question. So that question is going to be, find the probability of at least one red. So the question is at least one red. Now at least one red, if you do just by plain permutation, you will see that means red and red has at least one red, red and blue has at least one red, blue and red has at least one red, except for blue and blue, everything has at least one red. So there are two approaches, just like different color and not same color, there are two approaches to this. So one is to do all the permutations that are possible, red and red or red and blue or blue and red, all these permutations, that is at least one red. Or an easier way of dealing with the same math is the not rule, or you can just write at least one red is the same as not blue and blue. That means from the total probability of all the sample space, red and red, red and blue, blue and red, blue and blue, of all the possible sample space, if you just remove blue and blue from the total sample space, you are left with these three. As a result, it's the same as 1 minus probability of blue and blue, and that is going to give you at least one red. That is much faster. So it is better to do this using the NOT rule, and it is better to do this using the NOT rule for when you have two options and removing two items. Of course, it's not going to be the same if there were two options and removing three items. We'll see that in a moment. So now let's write down the probability. So the probability that we have is, we have one red here in this branch, the first red. So there are 5 items out of total 8. Okay, so if you take one red, this is the probability. So what is the first one? Blue. One blue, there are 3 items and you remove out of 8 items. So basic concept of probability, as we know, is number of event divided by total option. So now with this, what we can do is now the second red. So if you have removed one red, so the total will reduce by 1, and since red has also been removed, so there will be 4. Again, remove one blue. If you have removed one blue already, so the total will reduce by 1, 7, and you have removed one blue, so this will be 2 by 7. Now if you have removed one red already, the total will be 7, but you haven't removed any blue, so that will be 3 out of 7. And again, you have to remove the blue but not any red, so the total will reduce. It will be 7 and it will be 5 out of 7. So that's how you fill up the tree diagram. And then this is going to be, we can basically, what we can do is, red and red is going to be 5 by 8 into 4 by 7, or 3 by 8 into 2 by 7. So that is the probability of same color. Now in case of different color, I'm going to go with not same color, so that will be 1 minus the probability that we found over here. So if you do the calculation, when you do probability calculations, you don't need brackets actually, because the calculator only needs to understand bracket when it's dividing. No, and even for all calculators doesn't need that. Some calculators need brackets for division. So here you can just directly do this. So this is 5 by 8 multiplied by 4 by 7, and then plus 3 by 8 multiplied by 2 by 7. So this turns out to be 13 by 28. So 13 by 28, this will be 1 minus 13 by 28, and 1 minus 13 by 28 means 15 by 28. So this is 15 by 28. Now here this is going to be 1 minus blue blue. That is much easier for finding not blue blue, meaning the question is actually at least one red. So 1 minus blue and blue is 3 by 8 into 2 by 7. It's much easier to do this calculation this way. And this turns out to be, so 1 minus 3 by 8 multiplied by 2 by 7. And this is 25 by 28. So this is, so 25 by 28. If you had done the calculation with this, you would end up with the same value, 25 by 28. And similarly, if you had done the calculation with different color, you will end up with the same value as 15 by 28. So this is how it goes. So this is two options, and you're removing two items without replacement.